Next, we will look at sorting data frames. First, we'll want to sort a data frame based on the index. So if I take my Lakers dictionary and I create a data frame, PD data frame, taking the input data frame, and then let's give it an index, override it, and put it out of order. 1, 4, 6, 2, 3, 5, 0, 7. And let's save this as an unsorted DF. If we print the data frame, we can see that the index is not sorted numerically. It goes 1, then 4, then 6, then 2. To change this, we run the sortIndex method. This will take the index numbers and put them in ascending order. So if we took the unsorted data frame and we run the sortIndex method, and again, rather than dealing with the in-place parameter, sorted df. And now if we print this, we'll see that the indexes go from 0 to 7 in ascending order. Beautiful. The rows are rearranged based on the index number, but more often than not, we're going to want to sort based on values in a column. We can sort based on values of a data frame column by specifying the column name we want to sort as an inputted parameter to the sort values method. So for example, we can sort the values of this sorted data frame by the point per game column. So here it's out of order, but if we took the sorted df and then run the sort values method, we pass in the name of the column we want to sort. And again, we'll say this is sorted points data frame. Run this, and if we print it, we'll see that the points per game is now going from low to high. If we want to explicitly have it go in a certain order, then we can pass another argument, which is ascending. To have it ascend, which is going from smallest to largest, you set it equal to true, which is the default. That's why even though we didn't have ascending equals false here, that was the default, so it sorted anyway. And if we wanted to go from largest to smallest, aka descending order, then we set the input ascending equal to false. So again, let's take this. We'll add in the parameter ascending equals false. And let's override our current data frame. And now if we print it, it goes in descending order, so the most points per game to the lowest. There are times when the data frame can have some missing values, and we may want to identify these by putting them at the top or the bottom of the data frame when sorting. To handle this, we pass another argument called the NA position, and then specify it to be either first or last. So if I create a new dictionary and add in some non-values here, and we create this, and let's just call this df missing. And now if we want to sort the values again on our df missing data frame, we're going to sort the points per game column. We want it to be in descending order, which means ascending is equal to false. And this new parameter is going to be the NA position, and it can take either first or last. Let's put it at the top of our data frame. And again, Let's just save this into a data frame. And if we print it, we'll see that the non-values are at the top. And just to call out our in-place argument, if you remember that from a previous section, when we sort values, we are creating a new data frame. But if you don't want to create a new data frame after sorting the values of a column, and you'd rather overwrite the original data frame, then you can just pass the in-place argument and set it equal to true. Okay, so there may also be times when we want to sort a data frame based on values of multiple columns. To do this, we pass in a list of columns as an argument for the sort value method. The order of the sorting will depend on the order of the columns you pass in. So for example, if we again go back to our original Lakers data frame, and let's create a new data frame, just set it equal to df. And now if we want to df sort values and we want to do multiple values, we pass in a list. So the first list will be point per game column, followed by the assist per game column. And we want this to be descending, so we'll say ascending equals false. And what I'm going to do to make an example is actually change one of the stats so it is identical. So let's run through this again quickly. Great. And then sort by 2. And if we print this, we'll see that it is in the points per game order and then assists per game. And again, you'll see why I set the 18.7 equal for Kuzma and Ingram. And what it would do is the tiebreaker is look at the second column, which is assists per game. And since Brandon had 3.0 assists per game versus the 2.5, Brandon would be ahead of him. And remember, we could also pass in a Python list instead of using the bracket notation if we prefer that syntax. Let's look at filtering next.